We have looked at trig functions for some time now. We've developed past the idea of thinking about them just in triangles, just as ratios. We're now developing thinking about them as functions, okay? We don't leave the triangle understanding, as you've noticed many times, even when we were looking at graphs, right? And we were trying to establish this. Or I think it was swapped. But it doesn't matter. It's the same both ways. This is very easy to prove with a triangle. You just draw the triangle, right? So we don't leave triangles behind, but we're moving past them and noticing that trig relates to a whole bunch of other things. So much so, in fact, that the trig functions themselves, you can work with them even when you don't know what the angles are, okay? So we're going to explore this a little more. Here's an example of a question. If you know what the value of one trig function value is, right? Sine theta equals 7 on 25, an actual number. On the basis of that, evaluate cosine. Okay, now just before we launch into answering this question, why would we ever ask this? Like, what's the point, good morning, behind a question like this, apart from just mathematical curiosity? Well, I'll tell you very quickly, okay? Over on the side here, do you remember when we expanded the idea of the trig functions being in a triangle, we went to the unit circle? Do you remember that? Okay. We said, all right, imagine the Cartesian plane around this, and you'd have theta here. You've got a right angle coming up off of the x-axis. That's here. Okay. Now, on the unit circle, the hypotenuse is equal to... On the unit circle, the hypotenuse is equal to 1. Thank you. We're awake, okay? And then on the basis of that, you can very quickly determine that these two sides here are going to be cos theta and sine theta, right? And that's where we got the fact that the coordinates of any given point on the circumference of the unit circle, right, like that point, are cos theta, sine theta. Okay? And you can see here that if I have something going off at an angle, right, at an angle, cos and sine frequently refer to the horizontal and vertical components of whatever you're looking at, okay? Example, if what you've got here, right, thinking forward to projectile motion, is a point of origin and an object being fired off at an angle at a certain velocity, okay? You're like, I'm going to aim upwards at 45 degrees and I'm going to throw it at 30 meters a second or something like that, okay? Because I've got a really good arm, right? Now, actually, it's not that. Well, anyway, I haven't done the experiment.
It's like no gravity.
What we would do here to understand the situation, and it's what we will do when we go to projectile motion, is we will split up this movement at an angle into its horizontal and vertical components, and they're cos and sine, right? So sometimes you know one and you want to find out the other. I'll give you one other quick example. Again, going on this same thing, but if instead you've got a mass, right? Some object over here, and it's attached to a string. And I illustrated it like this before, right? And if you are rotating it around a central point, because the object is moving in a circle, we call this, unsurprisingly, circular motion, okay? Now, how is this object moving around? We alluded to this before. The point is that it's moving at an angle, like that, perpendicular to the radius, which we've proved, okay? But being that the movement's at an angle, it's going to have a horizontal and a vertical component, right? So in order to work with this thing, we have to separate out these parts. One of them will be cosine and one will be sine. So this is why, like, this question is very much in a vacuum. You're like, what is this on about, okay? Well, it's leading there, okay? So think about these two things as part of motion. That's where we're going to head eventually. So how do I solve it? The first thing I'm going to do is I'm going to say, well, how would I just do this? Like, how would I visualize this thing? Sine theta equals 7 on 25. I said even though we've moved beyond triangles, we don't move away from triangles. We keep them as our understanding of trig. So let's draw a triangle. If I draw a triangle like this, right angled triangle, okay. Excuse me. If I put theta in the corner, and I know that sine theta is 7 on 25, sine is which ratio? Which two sides? Opposite on hypotenuse. Opposite on hypotenuse, okay? So I've got 7 over 25, right? Now, just keep in mind, those two numbers could be 14 and 50, or 21 and 75, or any other combination, because all of these triangles can be similar. But this will be the simplest one. It's the simplest ratio. Okay, now, I know it's a right angled triangle, right? So we're going to get to this third side in a second. But suppose we didn't, right? How would we answer this question, right? Well, I can work out, if I want cos theta, I need to know what theta is, right? So directly from here, I can make this statement. I can say sine theta equals, now, you've seen this function before and you've met it in year 9 when you first learnt trig and you're like, oh look, we can find angles if we know what the sides are, okay? So this is sine inverse. It is a -1 up there, but it doesn't mean 1 over sine because that's cosec. Okay, so this is sine inverse, it's its own thing. You can go for your calculator. I actually would like you to get your calculator out now. And you can punch this in, okay? Now, you can already anticipate, because this thing in here is not a half, it's not √3/2, it's not 1 on √3, it's not a nice exact value that we are familiar with, right? When you punch in sine inverse 7 on 25 and press enter, which I'd like you to do now, you should expect some sort of random decimal garbage out of there, right? So 7 divided by 25. Okay, so what do we have? Just give me to the nearest degree. That's all I want. Yeah. 16 degrees, thank you. Just 16. I just want a ballpark, okay? Now, don't clear that. Don't clear it. Now that I know what theta is, and even though I haven't written down what it is exactly, this has got it, right? I can now say, therefore, cos theta is equal to, and I just say cos and answer, right? Cos, answer. And I get a number, right? And I get an exact number. Now you can probably see that's kind of suspicious, right? Weird decimal garbage, but you end up with something nice. And again, it's not that surprising based on this triangle that we've got here. What might be a better, less awkward, less time-consuming approach to working out cosine? Yeah, G. Okay, fantastic. All I need, because I've got a right angle triangle here, is use Pythagoras down here, okay? We know what this is going to be equal to, right? But just in case it's not a nice Pythagorean triad, the way that I would get this is the square root of the hypotenuse squared minus the other side squared, which sure enough will give you 24, okay? 7, 24, 25 is one of the uncommon Pythagorean triads after 5, 12, 13. Okay? So a better approach to this would be, rather than going this route and introducing a sine inverse and this decimal and all that kind of thing, is just to go straight here, right? Identify what this third side is by Pythagoras, right? And then you can just read off. Therefore, cos theta equals 24 on 25. That's all you need to do. You don't need to appeal to a calculator to do this. Does that make sense? Do you agree with that? Is that okay? Except there's a problem. There's a problem. A wee little problem. I might be right, but I might not be, okay? Because there was a very scarce amount of information provided to you in this question, right? And the first step that I made, I didn't highlight it to you so you wouldn't spot it, but I wonder if anyone has. The first step that I made added information to this question that wasn't there. What was the first step that I made? Yeah, can you get it? Very good. So I popped a triangle in here. That was a way of understanding it, right? As soon as I'm in a triangle, my value for theta is acute. I should say, as soon as I'm in a right angle triangle, my theta is acute, okay? Now, you might think, well, what's the big deal, okay? You can go ahead, you can try this, right? And you'll still end up, like, this is a legitimate answer. But what if theta were not acute, okay? Just quickly, underneath where you've drawn this, okay? Draw for me a small set of axes, but make it horizontally very long, okay? Just for the sake of illustration, I'm going to draw sine theta on here. And I'm going to draw more than I usually do. We usually go from 0 to 360. I'm going to go a little further. So I've gone from 0 to 1,260? I don't know, some awkward number, okay? So I've gone further than I normally do. And the reason why is to highlight the fact that if sine theta equals 7 on 25, there is not just one solution. The calculator has only told us one solution, but there's a whole bunch of them. Watch, how do I show this? Well, the range of sine, -1 to 1, range is a y value, domain is all real values of x. So if that's where 1 is, where's 7 on 25, like roughly? Give me a ballpark. It's like like a third the way up. It's less than half, isn't it? Okay. So I'm just going to roughly put that in. I'm going to draw it in. It's something like this. Is that okay? Roughly. That's y equals 7 on 25. So sine theta equals 7 on 25 means where do these two things intersect? Answer: a lot of places. In fact, there's an infinite set of solutions to sine theta equals 7 on 25, right? Now, ordinarily, that wouldn't be that big a deal, right? But it causes us problems if we have a look at these and what cosine is equal to for those other values, okay? Example, we said before, as soon as we drew the triangle, we were locked in to this solution, the acute solution, the first solution the calculator could find, okay? Well, the only one that it's programmed to find. But immediately you can see there's another solution right there, right? Now, let's just think in terms of domain first, right? This is 0, 90, 180, 270, 360, okay? Start to familiarize yourself with the features of this and where they exist. So here's 0 to 90, right? In there, there's our acute solution. So where is this second solution in terms of domain? In terms of domain. It's between?
Second and third quadrant.
Okay, so I can talk in terms of quadrants, or what I'm trying to get at is what are the values that go along with that? So saying quadrant, not quite the same as saying domain. You'd say theta is between 90 and 100 degrees. Or you could say, alternatively, second quadrant, okay? So I'm looking at an obtuse angle, okay? But what does cosine do when theta is obtuse? What does cosine do? If you can either mentally draw it, or you can think back to this guy. What's it doing? It's negative, isn't it? It's negative, okay? So to verify this, let's just do this actual number. Go back to when you did sine inverse of 7 on 25. Punch that back into your calculator, okay? Okay, now you'll get that familiar 16.26 whatever, okay? That's coming forward from the origin. To get the obtuse equivalence, right, the obtuse equivalent of that angle, I've got to go 180 minus that angle, right? So I'm now considering theta equals 180 degrees minus sine inverse of that, okay? So again, just so I can write it conveniently, what am I going to get? It's just going to be 164. Right, you can get the actual decimal. I would like us to do 180 minus the answer. Okay, so you get your 163 point blah, 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 blah. Now, I'm going to repeat what I did here, just to verify and be really sure, right? I'm now going to go, therefore, cos theta is equal to, and when you do cos answer, as we predicted, you get the same magnitude. Right? It's still 24 and 25, right? But you get a minus sign. Because in the second quadrant, when theta is obtuse, okay, cosine takes on a different sign. So, we need two pieces of information here, right? In order to work out one trig function from another one, firstly, you just need a number, right? And then you can do Pythagoras. But secondly, you actually need a bit of a restriction. I kind of left this off, right? You need to know, for example, in here, and theta is acute, or theta is obtuse, or theta is whatever. They might give you a domain restriction to actually say it, okay? But if they don't provide you that, you can't conclusively know which one you are. Are you this one, or are you that one? Does that make sense?